The final video of AP sample test number 3 is what we're going to be looking at today. This is non-calculator. You can have your calculator out if you want to check something, but we shouldn't be using it. We should be able to do all of this by hand. Let's go ahead and jump right into it. Ooh, this is interesting. I have to say that a lot, but it's because it's always interesting. It says the region R, so we're talking about area. It's bounded by some graphs, and we got these points on here. This picture is going to be kind of our guide, our key for all these type of answers. And we got to do these 4 things. Show that A equals B minus 3. So I got to show that somehow, no matter where I am, that these 2 things are going to be equal to each other. Find the numerical value of A and B. I got to figure out what A and B are, and then I got to write an equation for this line, and then I got to set up an integral for this area in here. So that's where we're going. Let's start with part A. Show that A equals B minus 3. Well, I would love to have this picture on the other slide just so I can kind of reference what's going on. So I have this picture, and what I want to do is show that this point right here, A, the x value A, is equal to B minus 3. And how would I do that? Well, I know that from the original equations here, we got x squared minus 3 and x minus 3 quantity squared are going to be our function. So let's start out with that. How do I know that A equals B minus 3? Well, I'm guessing that it has to do something with it. As I'm reading this, I know that there's some point A here, and that it touches another line B that's tangent there. And if for both of those to be tangent, they also have to have the same slope. So let's go ahead and jump to part B. See if we can figure out A and B. It says show that A equals B minus 3. I'm not sure what they're really looking for here, but the general idea is that it's going to be 3 less than that. Well, let's go to this next one, part B. So if we know that A equals B minus 3 from part 1, that might help us, and we might come back to that, but let's go ahead and jump into these 2 points here. Now what I find interesting is we're using 2 separate graphs with a common tangent line. If it has a common tangent line, what you should be thinking about then is how does that relate between the 2 graphs? What do the 2 graphs have in common at that specific point? Well, they don't have the x and y coordinates in common. Those are completely different. But they do have a common slope. That means it's a common slope. It's got to be the same slope for the first graph as it is for the second graph. So if I were to try and figure out what those pieces are, we have one function here. This function is x squared minus 3, and this function right here is x minus 3 quantity squared. I can find the derivatives for those and make them the same. Excuse me, I have to. I really have to. So I need to figure out what that slope is. Well, let's go about trying to figure that out. If I say that f prime of x has to equal g prime of x, I can actually figure out what that's going to be. It's got to be the same slope at each of these 2 places here. Well, so let's figure out what that slope would be. F prime of x, so that's x squared minus 3. We're going to be taking the derivative of that. And then over here we have g prime of x, so that's the derivative of x minus 3 quantity squared. So then that means that if we take the derivative of the first one, we're going to get 2x equals, and then over here we're going to have a chain rule, so it's going to be 2 times something to the first power, then times the derivative of the inside. So we've got x minus 3 here, times the derivative of the inside is just 1. If I were to simplify this out a little bit further, that means I have 2x equals 2x minus 6 times 1. class is coming up with something that's a little bit interesting, because this you might be thinking, well, this x and this x, aren't they the same? Well, not exactly, because this over here this is actually a, so I could say a squared minus 3, and this is b. This is some other point, b minus 3. So let's see what we got happening there. I'm going to replace these x's with a's and these x's with b's. So it means I have 2a equals 2 times b minus 3 to the first power. And over here we have 2a equals 2b minus 6. And we need to solve that. Well, this is probably actually our answer for that first one. Because if we take the derivative, set both of those equal to each other, I'm going to copy and paste all this that first page. That's what they were looking for. So I'm going to copy. Here we go back to the first, paste it here, and then I'll delete the pieces that I don't need. So we'll take that out. Take one of these out. We got the other one in there. There we go. All right. So then if I kind of divide all of this by 2 here, that's going to give me a equals b minus 3. It's kind of clever, actually, way of showing that, because I know the slopes are in common. So if I plug in a into f prime and b into g prime, that should give me each of these values here. And that gives me that a is b minus 3. So then I just have to figure out what those 2 points a and b are. So let's go about trying to do that now. So if I clear these annotations, and I know that I have a point here, and I have a point here, and I'm trying to figure out what those 2 points are. Well, one of the things that's kind of interesting is that both of these lie on the same line. And I don't know what this slope is per se, but I could use this a and b stuff to plug it in as a slope. Let's start with that. Let's see what the slope actually equals. Well, we know that it'd be y2 minus y1 over x2 minus x1. So let's see what we have going on there. Y2 minus y1, the difference of the y's, so this is going to be b minus 3 quantity squared minus a squared minus 3 over, then the x's are just going to be b minus a. And then we have here, we don't know what this slope is, but we know that it's equal to this. And so if we were to simplify that, that means we got b squared minus 6b plus 9 for that first term. And then this next couple of terms here, we actually have to subtract the whole thing, so I should group that. So it's going to be minus a squared minus 3 all over b minus a. So that means I have b squared minus a squared minus 6b plus 6 all over b minus a. You might be saying, wow, it looks like you can factor that out. Well, it would have just factored out to this stuff up here. That's probably what we would be doing. So the slope m equals this. We have to know that a and b are equal to, or not equal to each other, but they have a relationship. From the first one, we know that a equals b minus 3. So I'm going to make that substitution. That means I have b squared minus b minus 3 quantity squared minus 6b plus 6 over b minus, and then in here we got b minus 3. And that's our slope. Does that help us at all? Not exactly. So let's go ahead and keep working our way through this here. One of the things that I notice as we're looking at this piece here, I think some pieces are going to be canceling out. So let's see what that would happen. What would happen with that? Because if we can figure out the slope, then we can actually solve for the other pieces as well. So if I have b squared minus, now this part's going to be in parentheses here, we got b squared minus 6b plus 9. And we got minus 6b plus 6. And we have b minus b plus 3 if I distribute this negative for these two terms here. Well, the b minus b down there is going to go away. Now, a bunch of stuff is going to cancel out, so watch carefully. B squared minus b squared. Negative 6b is positive minus 6b, so that's going to be gone. And then this negative goes over to this negative 9. So then I have a negative 9 plus 6. Is that correct there? So we have this negative, this is going to be a positive 9. I feel like I'm missing something here. This is 9, and then we got minus 3. That was a squared minus 3. Oh, this was a plus, which makes this 9 plus 3. That makes us 12. Because this negative was distributed. You guys probably caught that earlier, but just to double check. So that means this part's 12 as well. It's not 6. So that's 12 there. And plus 12, because that's 9 plus 3, which is 12. And then here we're going to have a negative 9, and this is a 12. So negative 9 plus 12 is going to make 3. So we have a 3 on top and a 3 on bottom. So the slope equals 1. Wow. All that work to figure out that the slope equals 1. Well, I have some more information here, because if I know that the slope equals 1, then I actually can start trying to figure out what x equals for some of the other pieces. So let's take this point, for example. I know that that's on the function x squared minus 3. So that's f of x equals x squared minus 3. And then I notice something even more than that. I notice that if I were to take f prime of x, or f prime of a, how about that? F prime of a, that I know that that equals 1, because the slope at a equals 1. The slope at a equals 1. And I also know what f prime of a equals in terms of just algebra, because f prime of x equals 2x, so f prime of a equals 2a. So then what is a? Well, if I solve this piece here, divide by 2 on both sides, 1/2 equals a. Well, then I know that b is actually bigger than that, because a is equal to b minus 3. So 1/2 is equal to b minus 3. I add 3 to both sides, and then I get 3.5 equals b. Wow, that is a lot of work. This is a tough question. Lots and lots of algebra. Let's see if we can go a little bit further than that. Whew. Next. Write an equation of the line t. That's the line that's underneath each of those. Oops, pressed the wrong button there. That's okay. We keep on going. So here was the piece that we had. Oh, we didn't want that. Let's take that away. We have these two functions here that look kind of like this, and they intersect at a point here at 2, 1, I believe. Let's go ahead and copy and paste this picture. Copy, paste. Clear those annotations. All right. So we're looking at this graph. We want to find the shaded region, or we don't want to find shaded region. We want to find the line tangent here. So to find this tangent line, remember a tangent line is just y minus y1 equals the slope times x minus x1. Well, we figured out what a is here. A is 1/2. A equals 1/2. Then to figure out a squared minus 3, the y value, so that's my x there. To find my y1, I'm going to do 1/2 squared minus 3, which is 1/4 minus 3. Or, if you were to actually evaluate that, that's 1/4 minus 3, that's about -2, 3/4 or negative 2.75, however you want to write it. So now I just got to plug in the pieces. I have an x1 and a y1. I have an m. Remember, m equals 1 from what we figured out. So the tangent line is going to be y minus y1, which is negative 2.75, equals m, the slope, which is 1, times x minus the x value, which is 1/2. Done. That was so fast, because all we needed was the y value, the x value, and the slope. And we had those. We just had to input them. So now we're looking at, let's go ahead and put this picture back on here so we can see what we're doing. As we look at this, we're trying to find this region here. And the region between two curves is always going to be the integral from left to right of top minus the bottom. And in this case, we have two integrals. It's really going to be the first one here, because this is f of x, and this is our line t. And then the second one is going to be when we switch to g of x. So now we're at g of x over line t. So we got kind of a red and blue area. Let's do that. So this first area is blue, and then the second area is going to be red. So to find the blue area is going to be equal to the integral from, now we know what a is. We figured out what a is. It's 1/2. And we also know where it splits here. It's at 2, 1. So from 1/2 to 2 of f of x minus t. Remember, t is a function, y, a function of x, dx. Then we have the red area, area 2, our second area, is equal to the integral from 2. Now this goes right here. We figured out that b was 2.75. So from 2 to, oh, pardon me, not 2.75. It's 3.5, 3.5. 2 to 3.5, or 3.5 either way, of g of x minus t dx. And the total area then, the area total is just the sum of those. We'll call this area 1. Is area 1 plus area 2. Because this is an FRQ question and I've labeled them here and here as well, I can rewrite it like this. I don't have to, the R, which is the total area, I don't have to rewrite them again. I just say it's this one plus this one. Alright, that was a big question. Wow. Alright, let's do something a little more simple. Let f of x be a function defined by this. Notice that k is a constant, but we're just going to do our normal things. We're just going to treat k like a constant. On one interval is the function increasing. That means f prime of x is greater than 0. So that's what we got to figure out. When is it greater than 0? Is if the relative maximum value of f is 4, then what is the value of k? Well, we're going to figure out where the maximum value is. Then we're going to set that equal to 4. If we know the x value, then we can find the y value. And that'll help. Well, we have the x value and the y value, then we can solve for k. That's where we're going with that one. Find the interval where the function is concave up. Concave up means f double prime of x is greater than 0. The second derivative greater than 0. Find the relative minimum value of the function. For something to be a relative minimum value, we're looking at the first derivative. We're going to be going decreasing, then increasing. And in between, we get a min. So let's do this one step at a time. First, we do have a function. Let's go ahead and copy that just so we know what we're looking at here. We have this function right here. Clipboard, add this to this page, copy and paste. So this is the function that we're working with. F prime of x is going to help us find increasing interval. So when I take the derivative, that k of course goes away, and then because it's a constant, and constants don't change, therefore when you measure the rate of change, it's nothing. So this one right here, what's the derivative of the first term? It's just 12. Derivative of the second term is going to be 6x, so plus 6x. Derivative of the third term is going to be minus 6x squared. Now as I look at this, I'm trying to figure out when is this increasing. So I need to figure out when is this positive. When is it greater than 0? So what I'm going to do is I'm going to take this piece and I'm going to set it greater than 0. I can also factor it. I noticed that I can first pull out a 6, and just to make this a little bit easier, this is kind of not necessarily the way that a lot of people do it, but I'm going to get to it in just a second. 2 plus x minus x squared. And when you look at this, you're like, that looks hard to factor. Well, we kind of have something going on where we're still trying to do this, but one way to think about it is if you just kind of read it in opposite terms. But I can divide both sides by 6. Pardon me. I'm getting a little distracted here. Okay, divide both sides by 6, and I have 0 is less than 2 plus x minus x squared. I'm going to move everything over to the left side and make a 0 over on the right. Why would I do that? Because it's just a little bit easier to factor when you're dealing with a positive coefficient in front of the x squared term. That means on the left side it's going to be x squared minus x minus 2 is less than 0. This makes it a little bit easier to factor only because we're used to that. Not because it is easier, we're just more used to it. So if I were to factor this, that would be x minus 2 times x plus 1. Those wind up being my critical points, and I need to figure out when is that less than 0. So let's look at maybe a chart of what's going on. So we have x, then we got f prime of x, and then that's going to tell us something about f of x. So let's make these some straight lines here. I like to use gray when we're doing these. I don't know why. I think just because it doesn't hurt my eyes. So we'll put a -1 in there, and 2 in here, and we'll have another one there. And now we need to go horizontal, horizontal. Awesome. Can extend this a little bit. Alright, so if I were to look at this, I'm looking at critical points of x equals -1 and x equals 2. So I'm going to put -1 here and 2 here. And I know that at -1 it's going to equal 0 because this is going to equal 0. And at 2 it's going to be 0. So then I just need to check points in between. So I could check 0. I could also check -2 on the left side, and I could check 3 on the right side. So let's figure out what happens. If I plug in -2 into this, that first term is going to be negative. The second term is also going to be negative, and negative times a negative is positive. So this is positive. If I plug in 0, that's negative times a positive, so that's negative. If I plug in 3, that's a positive times a positive, that's also positive. So I know that I'm going up and then down and then up. And right here, so from negative infinity all the way up to I reach 0 here at -1, I have a positive slope. That's also known as increasing. And then from 2 all the way to positive infinity, I don't have any changes. I still have more positive slope, so that's also increasing. So f of x is increasing when f prime of x is positive. So f of x is increasing on what intervals? From negative infinity so what are we looking at? For when x is less than -1, or when x is greater than 3. There we go. Let's do part B. It says the relative maximum value of f is 4. So I can still use that stuff that I was looking at. I was looking at f prime and f, and then the original function, or the original values here. So we said that it was increasing, then decreasing, then increasing, and this point was our first critical point, which is at -1. So we have a at -1 we have a max. X equals -1 is where our maximum value is. If we know that, then we can actually kind of figure out what k is equal to, because it's saying that f of -1, f of our max value, max x, is going to equal 4. So f of -1 equals 4. Then what I'm trying to think about here is, so how can I use the other equation stuff to help me with that? So if I paste this equation back in here again, I'm going to fill in the pieces that I know using this information. So f of -1 is equal to, well, I just got to plug in -1. That's going to be k plus 12 times -1 plus 3 times -1 squared minus 2 times -1 cubed, and then that's going to be equal to 4. So we have k minus 12 plus 3, and this next term is going to be -1 cubed is -1, -1 times -2 is positive 2, and then all of that's going to be equal to 4. I just got to do the algebra here. So -12 plus 5 is going to be k minus 7 equals 4. Add 7 to both sides. Then we figure out that k equals 11. Boom. Check. Move on. Part C, find the interval where the function is concave up. Now we can kind of interpret this based on the first derivative, but it's usually easier to look at second derivative. So we have our function again. We took the first derivative. We figured that already, and we got f prime of x is equal to 12 plus 6x minus 6x squared. If we take the second derivative, f double prime of x, that first term is going to go to 0. Second term is going to become 6, and the third term is going to be minus 12x. And now we're looking for a change in concavity here. So the critical point for change in concavity is when f double prime equals 0, because that's the potential. How do I know it has to be at 0? That's the potential when we're changing from negative to positive. In order to change from negative to positive, you have to pass through 0. And that's a change in a function. So then we just see what happens at 0. So 0 equals 6 minus 12x, and if I do some algebra here, add 12x to the other side, and then we figure out that x equals 1/2. So that's where the potential change in concavity is going to be. Another way of looking at this, we could have factored it. It could have been 6 times x, or 2 minus, pardon me. Here we go. Erase that. 6 times 1 minus 2x. Now if I were to think about this function before and after 1/2, I know at x equals 1/2, f double prime of x equals 0. So what I want to look at is before and after. So if we're looking at x, f double prime of x, and then we got, how is that talking about the original function? So we have these possibilities here. We're at 1/2. We want to look at something before that, so maybe 0, and something after that. Let's say 1. So before 1/2 would be 0. If I plug in 0 into here, that's just 6. So that's positive. And if I plug in 1 into here, that's going to be negative. And in the middle, it's 0. So that means before 1/2, my second derivative was positive. That means I'm going to have an upward concavity. And then afterwards, I'm negative concavity. So it's concave up on the interval x is less than 1/2. We are concave up. For x is less than 1/2 because f double prime of x is greater than 0. That's my answer. Next. Find the relative minimum value of the function. Now this is a little bit different because we know where the relative minimum value is, but we don't know the actual value. The value is the y value of the function, the high or the low. So we want the lowest value of the function. Well, that happens if you guys go back and look at your work and part A. we figured out, was this where we figured it out? Yes, it was. It was just down here at the bottom of the screen. We figured out that there's going to be a min at x equals 2. So I just got to plug in 2, but I also got to realize that k equals 11. So I start with this original function, just like we've been using this entire time. But we know that k is really 11, and we're going to say that x equals 2. So f of 2 equals 11 plus 12 times 2 plus 3 times 2 squared minus 2 times 2 cubed. I'm going to stop there. Why? Because I'm done. I can plug this into a calculator if I needed to, but this is my actual answer. You do not need to simplify. Let the grader do the math. Next. Let f be a function defined on the closed interval -3 to 9, like here. The graph of s consisting of 3 line segments is shown. Let g of x equal the integral from 0 to x. Now think about this. This is the area from 0 to x. That's what it literally means. So let's take a look at it. We need that picture. So here's our picture. So if it says find g of 4.5, g of 4.5 is going to be the area from 0 to 4.5. Alright, so the area from 0 to 4.5, if I look at this area here, so I got this and this, and then we're going all the way to here. So what's this positive area? Well, that's quite a bit of calculations actually. I notice that this is 4.5 there. Here we have a height of 3. So this is 4.5. That means that this up here is 1.5, and that's 3 wide. Now here's something really interesting, you guys. Some of you might think of doing this, but if I take this red triangle here, it's actually congruent to this triangle here because it's right triangle and it's got the same base and height. This is 1.5 times 3. So to find that area, instead of counting it here, I'm going to count it on the second one there. So I'm not going to do this first one because now I've made a rectangle, and rectangles rock. So I want to find the area of this rectangle. Well, the bottom of that rectangle is going to be 4.5, and the left side of that rectangle is 3. So g of 4.5 equals 3 times 4.5. And that's it. I don't need to simplify because I'm done. 4.5 times 3 I could figure out, but I don't need to. G prime of 4.5. Well, let's think about g prime of x. G of x equals the integral from 0 to x of f. So g prime of x means take the derivative of this. It's really just f of x. So that means, what is my value at 4.5? G prime of 4.5 is equal to f of 4.5, which equals 0. Now, similarly, not exactly the same, but similarly, when I'm looking at g double prime of x, how do I get from g prime to g double prime of x? That's like going from f of x and just going down one level in derivatives, and we're going to go to f prime of x. So g double prime of x is f prime of x. So g double prime of x is equal to the slope of f. So g double prime of 4.5 is equal to the slope at 4.5. What is that slope? Well, here's 4.5, and to figure out the slope, here's a straight line. It looks like it's going down 2 over 1. So g double prime of 4.5 is equal to 2 over 1. Part B. Here, I'll go back for those of you that missed it. Pause the video if you need to. I'm moving on. Ready, set, pause. Find the average value of f on the interval -3 to 5. Show the work that leads to your answer. Well, average value is pretty easy to do. It's just remembering that the average of something is the sum divided by the number of pieces. So if we're looking from -3 to 5, that means that we're doing the integral from -3 to 5 of f of x, but we're going to divide by that distance traveled, which is in this case 5 minus -3. Remember, this is just the area from -3 to 5 divided by that. So it's going to be that area divided by 8. Let's figure out what that area is. So we start here, and we're going all the way to 5. Now this is kind of interesting because I already know the area from 0 to 4.5. I know that in here we have, what was this? This was 3 times 4.5. Let's go ahead and color that in something. We'll do that in purple. So I know that this area that I'm outlining in purple is 3 times 4.5. So that purple area, we'll call that area 2. That's equal to 3 times 4.5. The first area, let's pick a color. How about brown? Area 1. That's this area here. Well, the two heights of this trapezoid here, this is 4.5 on this height. This height here is 6, and this width is 3. And the area of a trapezoid is the sum of these two bases times the height divided by 2. So we got 6 plus 4.5 times the height, which is 3, and all of that divided by 2. And then the area of the third one, we'll do that in red down here. Area 3, so let's do some calculus here. The integral of f from -3 to 0 is equal to area 1, f dx. And then the integral from 0 to 4.5 of f of x is equal to this one. And then the last one is just from 4.5 to 5 of f of x is equal to area 3, which is really, it's just a triangle with half for the base and 1 for the height. So it's half base times height, half times the height, which is 1. And here's where we're going to get super simplified here. This piece is going to be area 1 plus area 2 plus area 3 all divided by 8. So this is my answer. Why do I need to not do any more? Because it's an FRQ and you don't need to simplify. Could you? Yes. Do you need to? No. Let's move on. Actually, go back. People have been requesting that we pause a little bit, so I'm pausing. If you need to pause the video, I'm gone. Find the x-coordinate of any points of inflection of G. Justify your answer. Any points of inflection. A point of inflection is a change in concavity. It's also considered, another way to look at it is it's when f double prime of x changes sign. What we're looking for then, an f double prime of x, in this case, equals g prime of x. Oh, pardon me. Let's take a step back here. This is asking when g double prime of x changes sign. So in terms of f, which is the picture that we do have, that's when f prime of x changes sign. And that's the slope of f. So we're looking for when does the slope of f change from positive to negative or from negative to positive? Well, let's take a look at the picture. Does this slope ever change from positive to negative or negative to positive? Sure does, right there, because right here it's negative, and then after that it's positive. And in between, doesn't matter what it is, but it is going to be changing. So, at x equals 5, there is a point of inflection because g double prime of x, which equals point of inflection of g, I should say, because g double prime of x, which equals f prime of x, changes sign. That's it. Is there a part D? There is. Find the coordinates of all maximum points of g. When does g have a maximum point? Well, we can think about when g prime of x equals 0. And g prime of x is really equal to f of x. That's the only type of place that would happen. And that means that g prime of x has to change from negative to positive. So that means that f prime of x, or f of x, pardon me, f of x has to go from negative to positive. Does that ever happen? I don't think so, but just to double check here. It does happen, actually, here. Because before this, f is negative, and after it, f is positive. So that means at x equals 7, g is at a maximum. Ooh, there's something we're missing here. I don't know if you guys are catching it. But it says find all coordinates, not just the x value, but also the y value. So we have to not only know that it's x equals 7, we got to find g of 7. Wow. Well, actually, no, that wouldn't be. Find coordinates of all maximum points of g. Ooh, let's take a step back here. You guys are going to hate me for a second. If we're trying to find maximum of g, that's trying to figure out when this area is a maximum. So we have potential places. First of all, it would be here, here, and here. How do I know that? How do I know that? Well, if I look at the area from 0 to here, we know that that's 3 times 4.5. We also know that if we're trying to find the area here, some people might think that it would be there. But now we're moving backwards because g of x equals the integral from 0 to x of f of x dx. So if this x up here were -3, that's like saying the area from 0 to -3 of f of x dx. And notice that this is kind of backwards from what we're used to, so that would really be negative times the integral from -3 to 0 of f of x dx. So this black area here, this is negative. And after we hit this point, notice that this area here and this area here, these are both symmetrical. So this point and this point are going to be the same. So, or no, those aren't going to be the same. Pardon me. This point and the end point here. So at 4.5 and at 9, at x equals 4.5 and at x equals 9, those two pieces are equal to each other. Oh, pardon me. That means that f of x, so f of 4.5 is equal to f of 9. There we go. That's what we're trying to say, that the y values are equal. Or the area is equal, I guess you could say. That being said, since this area out here is negative, no way is that going to work. And that means that here we hit a maximum, and at 9 we come back to the same point. So the coordinates, well, at 4.5 we hit a maximum. And we know that that area is going to be 3 times 4.5. So this is one of the maxes. The second one would be the same value, which is at the end here. So that's going to be at 9, and this is the same y value, y, 3 times 4.5. I know this was kind of all over the place, but I'm really just trying to give you guys some guidance in how you can look at these questions. You don't have to do them this way. And now we are done.